Today we're doing matrix operations. This is our second day in section 8.3. So like I said, today we're going to be discussing how to multiply matrices. This is something we went over last year, so hopefully you remember it. So in order to multiply these matrices, the idea is you always go row by column. So it's always row by column. So taking my first row and I'm matching it up with my first column. So I'm taking A times E, and then I'm adding it to the product of B and G. And now I'm going to take this value again. So now I'm taking A and B and I'm pairing it up with FH. And because I'm taking row 1, column 2, this answer goes in row 1, column 2 spot. So I'm taking AF plus BH. Now we're moving down to the next spot. So now we're taking CD and matching it up with EG. So I have C times E plus DG. And then lastly, we're taking CD and pairing it up with FH. So I have CF plus DH. So we're going to go through and we'll do one example where we're just going to practice this. I'm actually going to tell you the trick to making sure they can multiply. So M and N would be like it's row by column, and N and P would be the other row by column. So in order for these to work, M and N must be the same. Okay, so they must be the same. And if they are the same, your final order is going to be the M by P. So your order will be those outside values. So here for our first example, we have a 2 by 2 multiplying it by 2 by 2. So if you kind of write that out, because these are the same, I can actually multiply them together, and our final answer will be a 2 by 2. So I'm going to write it full out so you can see what we're multiplying together. So for column 1, row 1, column 1, we're using these values. So I'm doing 2 times 0 plus 3 times 5. Moving over, so still using row 1, now I'm moving over to column 2. So I'm doing 2 times 1 plus 3 times 6. Then I'm moving to row 2, column 1. So 4 times 0 plus 7 times 5. And now row 2, column 2. So 4 times 1 plus 7 times 6. Now you just need to go through and calculate that. So 2 times 0 is 0. Plus 15. So in our first spot we get 15. This is 2, this is 18. So in the next spot we get 20. This is 0, this is 35. So we get 35. This is 4, this is 42. So in the last spot we get 46. So there is our answer by multiplying A times B. So let's look at some unique cases. So here, matrix A is a 1 by 3. Matrix B is a 3 by 1. So first thing I want us to find is AB. So if we were to find AB, I'm taking a 1 by 3, and I'm timesing it by a 3 by 1. So because these middle numbers match, I can do it, and my result's going to be a 1 by 1. So the reason it's going to be a 1 by 1 is I have one row, and that gets matched up with one column. So when I put these together, I'm going to have a 1 by 1, and I'm going to get that by doing 1 times 4 plus 5 times 2 plus 3 times 6, which would equal 4, 10, 18, so 28, 32. So my 1 by 1 matrix is going to equal a 32. Now, when I do it the other way, B times A, I'm taking a 3 by 1 and timesing it by a 1 by 3. So my result's going to actually be a 3 by 3. So let me just write it out. Actually, let me go to the other screen so we have more room. So I'm doing 4, 5, 6 times by 1, 2, 3. So for my first row, row 1, I have to times it by column 1. So 4 times 1 is 4. Then I have to take row 2, column 2. So 4 times 2 is 8. Row 1, column 3 is 12. Now I'm moving on to my next row, and I'm using 5 times all 3. So I will get 5, 10, 15. Now I need to move to row 3, and row 3 needs to get multiplied to all 3 rows. So I'll get 6, 12, and 18. So these are two special cases where I have the same matrix, and when I switch the order I get very drastic results. Notice one of the answers I get a 3 by 3, where the other answer I got a 1 by 1. So we're going to do some practice on all different combinations tomorrow and exploring which matrices can actually be multiplied together.